My name's Dan. I'm from Untether, and everybody this week is saying, what the hell is a semiconductor company doing at an ag show? Well, we have AI in our name, and everything's AI, right? So we're in an Inno session pitch. We're going to pitch what we're doing in innovation, why we're doing it, and why we think the entire industry is going to benefit from the work we're doing. That's why we're here. So you can go out and see the demos, you can go boot the booth, and this is a feel-good thing. That's my picture I took out in Indiana with Swarm Farm pulling a weed it. Sprayer, Bex has cut their herbicide application by 80%. I have a little 3-year-old granddaughter who lives around the corner from that, and I love the fact that they're not spraying their fields. That's all good, it's great. Harvesters. When I was growing up in Missouri, the good thing about being on a farm is you get to drive the grain carts when you're very young. Dad's in the combine and 12-year-old driving a grain cart, not paying attention, and I got whooped every night because there's corn on the ground. Well, now we have synchronized grain carts. They're being driven by the combine, which has no drivers. It's all automatic. These are all feel-good things. The problem or the reality is they cost way too much. Okay, it's very hard. As the AgCo guy says, it's really hard for a farmer to spend $1.2 million on a weeder that they use for 3 weeks, right? The co-ops sometimes can get enough business to afford that, and there's some specialty people, and there's some funding from ESD in Canada. They'll fund half your AI adoption. So there's things happening, but not at the rate you need them to happen to affect the industry. Part of it is they move too slow. Some of these weeders out there run at 0.5, 1, 2 miles per hour. Okay, if you've got 800 acres, you can do 40 a day. Okay, so now I'm going to do weeding for 20 days on a $1 million machine, and it's full of 25-year-old computing technology. You all hear NVIDIA, you all know GPUs, they're all being used to train ChatGPT that we use to write our LinkedIn posts and da-da-da, and it's just a huge thing. But they're 25 years old, okay? And they draw too much power, they're too expensive, and they don't have enough performance. But every one of those tractors and implements out there are using NVIDIA GPUs. That's the problem in the industry. I said to somebody in our booth today, I said, well, to me, I loved my BlackBerry. When I got my BlackBerry, I was a happy camper. I could make a great call, and I could send a text or an email. That was a perfect solution. It was on my hip all the time. When I got up in the morning, I got my BlackBerry. I went to bed, I put it on the couch. What happened, though? BlackBerry's gone. You don't see any BlackBerries because they didn't take pictures. They didn't take videos. They didn't have an app store so you could buy things with it. It was simply a phone and an email system. It went away. Well, that's what's going to happen to GPUs. Nothing wrong with the BlackBerry. They're great things. Nothing wrong with a GPU. We built them to play games. That's what a GPU was for, a gaming console. Nobody ever said a GPU ought to drive a tractor. I wouldn't have any thought of doing that ever. Nobody said a GPU ought to spot a weed to shoot it. So why are we using all that? Well, it's because there wasn't a better solution, but there is now. So we started in the automotive industry. Our original funders were General Motors Ventures. We are building vision systems to drive cars. We've taken that technology and we brought it to AgTech. If a tractor runs over a pheasant in an Iowa field, the only guy upset is the farmer who didn't get to shoot it when he was hunting. You run over your 4-year-old girl on a tricycle, we have a national dilemma. So running self-autonomy in the fields is actually a good thing because we can get that technology, we can make revenue on it, and we can do some good for the industry. In defense, anybody who's got a vehicle should have a computer driving it. What do we care if we run over a bad guy in Afghanistan with a military vehicle? We really don't care. We're there to eliminate them. So collision avoidance, not such a bad thing. What about mining? You ever been to I live in Colorado, you go to a mine in Wyoming and you go, holy crap, how's that guy go home at night? He's got to be scared to death. You're running on roads that are exactly the size of the vehicle. You've got 6 inches either side. Well, we have GPS that's 2 centimeters accurate. We can drive that vehicle. Construction, Trimble just ran a compactor in Houston on a road. When they plan the road, they know exactly where the road is. Why do we have somebody driving a compactor in 120 degrees sunshine in Houston on 140 degrees tar? Why are we doing that? Well, there wasn't any other way to do it. Well, now there is. And AI accelerators are the ones that are doing that because it's cost effective, it's very simple, simplicity begets reliability, and it's available, right? We can ship these things now. So in the market today, this is what you'll find out there. It's a SysLogic box. It's a AGX GPU. It says it's the most powerful version you can get, and that's why we use it. But you're seeing as TOPS is tera operations per second. It's a calculation of how fast you can do math. We do 10 times as much as that. This is this box up here, I'm sorry, I should say by the mic. You're talking about 1/10 the power consumption. So if you want an electric or a solar vehicle, saving 600-700 watts by not having all these GPUs is one way you can electrify. Electrify is another good thing for the planet. We're all about climate change. The other thing is we can scale this. So ours are arrays. They're not computers. They're arrays of processors. So we can stretch that array to match the problem. 10 years from now, the models you're running in your tractor are going to be very, very different. You can tell by Tesla. You go back and see where Tesla was 10 years ago. They update their models every night from every vehicle that's running, gets uploaded, and they train their models and they improve them. That's what's going to happen in ag. So let's talk about carbon robotics. Great example. Big success story. When there's no funding in AgTech, suddenly they raise $30 million from NVIDIA. Everybody's like, that's great. It's a strategic investment. But on the left side, you see what it costs carbon robotics to do that. 700 watts of power. Probably with their investor giving them a discount, it's only $100,000. But that's $200,000 to the end user by the time they buy it. That's what's making vehicles way too expensive. Our one chip does more work than all of those 24 boxes that they have in that vehicle. So what you see on the left there, that's one box. Those 8 little green dots are each a GPU. You put 3 of those boxes down in the bottom picture and you mount it in that carbon robotics thing. And you haul it all through the field. And you've got basically spending all that fuel to haul all of this footlocker of computing when that one board does 3 times as much work, only 70 watts. So we can do 14 million, 12 million images per hour against their 4. So why wouldn't an AgTech vendor want something that's more performance, much less power? I can get it in weeks, not years, and it's 1/10 the cost. Why wouldn't that be a compelling reason? And our attitude is not, we're not saying anything bad about NVIDIA. NVIDIA to me is a BlackBerry. I've used NVIDIA playing games all my life. But we're saying if the industry is going to improve, this is the avenue that's going to take it there. So we started in automotive. What you'll find in automotive is AgTech is where we were 10 years ago. When cars first started being computerized, drive-by computers, everything was a unit. You had a brake unit, you had an engine unit, you had an ADAS unit, you had all these things all through your car, and you had cables everywhere. Turns out 11% of the weight of a Tesla is wires. So if you went to a modern computer technology based on buses, based on centralized computing, based on zones, we call them, and domains, you'll get rid of a lot of the weight in your tractor. Less weight, less soil compaction, less gases used. Everything gets better. So we're building basically a proposal for the AgTech industry that we call an AgBox. We want everybody to contribute. It's the democratization of computing for agriculture. Think if you're an investor. I have a friend that has 30 AgTech portfolio companies they've invested in. And I said to him, you've spent money on every one of those to go figure out how to do hardware. What if you spent it once and then everybody got the hardware? So out of this, we've put the 4 functionalities we think we've collected from all the AgTech. The top right, you can drive. That comes from the automotive stuff. You got to see what you're doing, and you got to know where you're at. It's position, perception, and location. On the left is robot control. You want to hook up to a weed it, you better tell it what to do, right? You're the robot, you're the tractor, so you got to have an interface to sprayers, thinners, cultivators. You got to have a standard interface. Think about if you went to buy a pad computer today, and it didn't work with anything. Oh, I want to get on the internet. Well, it takes an engineer about 12 hours to do that. AgTech vendors take months just to get their equipment to talk to each other. That's where the lack of standards is coming from, okay? Down in the bottom left is connectivity, right? You've got to talk in the fields, and everybody's got sensors, so as we're driving by, we might as well collect that data. In the bottom right, we store that data, and we communicate that data. So this AgBox would be open source, cost nothing to anybody. They can get this design. If you're only building self-driving, well, don't use the other stuff. If you want to add your secret sauce, you want to put security in because your data from your collecting from your sensors, add security. Software-defined vehicles is where we're at in automotive, and we're going to have software-defined AgTech. Okay, it's coming. History is defining that this is coming. We're here to prepare for that arrival, right? If everybody's using the same computing, all the phones have ARM processors in them, okay? x86 was, you have 2 vendors making x86. This is the same attitude. Take the expense out so that the entire industry floats. So investors, VCs have come in and said, well, we want to put some money in. Strategics have come, we want to put some money in, and we're going to set this alliance, just like Linux. If you're familiar with Linux, RISC-V and processors, you're going to have an AgTech, an AgBox alliance. The entire community defines what's in it. We have people like J Squared here from Canada, with Chris over here that are box manufacturers. So they'll build that box. If you want to change that box, that's what they do. They have a whole software group that can help you with their AI models in your AgBox. They can customize the electronics in it. They can change the mechanical. That's their function. That's why we partners. We have partners that, the other reality is the weeds in Australia are different than the weeds in Sacramento. Why are you carrying a John Deere tractor full of computers with every weed that's ever been invented in the earth, and you're in Sacramento? So you need to really get smart and only care about the crops and the weeds and the pests. The last presentation, my question I didn't ask was, do you have regional, because bugs are different around the world, right? Weeds are different around the world. And we can't build a world solution. It costs too much, takes too much power, it goes too slow. So customizing all that is part of our shtick here. So who's going to benefit? Well, this is from 2022, but I thought it was a pretty good chart. The key is technology for AgTech isn't in Silicon Valley. We're a semiconductor company. Robert, myself, we've lived in Silicon Valley all our lives. My wife's like, where are you going? You're going on another business trip. And I'm like, yeah, I'm stopping in Ames. I'm going to go up Sioux Falls and then over to Saskatoon. She's like, whoa. All your life you've gone to Silicon Valley, Portland, Austin. AgTech is out in the fields, and that's why we came here. We came here to talk to people and tell them there's a better way to do this. So all of these companies will benefit from an AgBox. And that's why we think we're accelerating AI. So that's our story. We're talking to people. We intend to kick off this box next month. We're getting people ready. We should have it in manufacturing shortly thereafter, because all of this technology is being donated. People are like, well, I can give you, we can take that we built for Ola, a card builder in India, and say, do you mind if we reuse that in AgTech? No, that's fine, because you're not building cars. You're not a competitor. Okay, can we borrow this from Trimble? Sure. Everybody benefits, so everybody puts their IP together. We make the product. We work with partners, make it available. Now, your vehicles are running faster, not 1 mile per hour, but 6, 7, 8. So your return on investment happens, right? If you've got 4,800 acres, now at 10 miles an hour, I can probably do that in 3-4 days. Okay, I have carrot farmers out in Greeley, Colorado I work with, and they're like, we love this because we don't want to be spraying herbicide. We just don't want to do it. but we can't make the economics work. We just can't do half a mile an hour and watch this Zamboni thing weighs 2,000 pounds snake its way across my field. We have to get better. This is why we're here. We think we can help the entire industry. We've taken the advance, we're taking the initiative. Our CEO came from Intel. Most of our founders came out of Altera in the semiconductor industry. We know how to build high-performance accelerators, and we're bringing it to AgTech. So, any questions, I'd be happy. We have a booth at D9 over here. Robert here's my partner, so anybody got any questions for us? You came just to ask a question, I bet. No?
About
All good.
6, 8 minutes.
Yes, sir.
I got it.
So you mentioned like similar to software-defined vehicles for agriculture, and so what kind of software components are you looking at making available? Because that's a big part of the software-defined initiatives. They all come with like.
So we have a whole software stack.
Okay.
So we can read Onyx for automotive. We can read PyTorch, whatever the AI models are being done and the AgTech models. We bring them in, we compile them, just like you would any software, and then we do a physical allocation to our arrays. So we have a whole software stack that comes with our technology. Okay, it's what I say is 90% push button. Okay, so when you're doing analysis, push the button and it works. But if you're going to put it in your final vehicle, you're going to fine-tune it. So we also have tools that are visual that help you do the final optimization so you can get as much performance as you want out of it. But yes, software is a huge part. And AI companies like us actually have more software engineers than chip designers. It's a reflection on how important software is to us. Anybody else? Cool. It's time for beer.
Beer 30, almost. Oh, question in the back. We got another one.
There you go. Way over in the dark.
Don't be shy. He's got about 10 minutes of time still.
If we are, for example, an organization who's like very NVIDIA forward, all the developers are fans of NVIDIA landscape. What is the journey that you guys offer for a company who's willing to consider switching, or like, do you guys have like salespeople who can like, or as educators to engineers, and like, what's the journey of new onboarding?
So I always say, I'm an engineer. I've been 40-some years designing chips. Engineers are allergic to change. They just don't like it. Makes them itch, makes them uncomfortable, it makes them nervous. And I'm like, well, how hard is it to, if you're using Outlook for email and I mandate you switch to Gmail, you're mad at me for 2 hours, 4 hours, 3 hours? You got to figure out, to add an attachment isn't here, it's there, but it's the same function, right? So CUDA is the NVIDIA's hold on the industry, because all engineers are like, we love CUDA, right? And I know probably 10 good CUDA programmers are great. Everybody else is marginal, okay? If the benefit is so big, people will pay the penalty. The penalty here is transitioning from one tool to another. It's a transition from a modular CPU, GPU kind of approach to a coprocessor, an accelerator. Our board plugs into a computer, so I'm like, you don't have any work to do. So the answer to, it's a bit dependent on the engineers, how deep they're in, if they've gone down. It's kind of like assembly language. If you wrote your software in assembly language, you're going to be much less willing to change to another language. If you've written it at a high-level language, now the difference between Rust and Python and C, so it gets to be easier. So what we're doing is providing the same functions as CUDA, but in our language, in our way of doing that. So it would be, we have a whole set of people that's their project. We work with the automotive guys and we say, okay, here's your CUDA stuff. We're going to show you how to do it in our world. And we're going to offer all this training and assistance, and we're going to do basically a pilot project to show the proof of concept. And we do that routinely with people, because that's the biggest issue. For me, I'm old enough, unfortunately, to remember everybody saying the same thing about, well, I'm going to buy a PC, and everybody buys an IBM PC. And I'm also old enough to know that that is exactly not true, because they all got fired. And everybody ended up buying better PCs, and IBM got out of the business. And that's what happened to BlackBerry, that's happened to Nortel, it happened to Nokia, Wing, you know, I can tell you I have a wall in my office that's the hall, it's a graveyard of technology. You know, there's an Apple Newton up there. You know how much money Apple spent on the Newton? Holy crap, it was incredible. So I think, like the BlackBerry, there was a lot of people when smartphones came out, the IT departments of the company I worked at, like, we're a BlackBerry company, don't you bring in no smartphone thing. The heck are you doing, you dumbass? And I'm like, it's a much better phone. I can actually take a picture of my sheet, and it goes right in my expense account, and I don't have to fill out a form. As a sales guy, that's huge. That's what I do all day is expense reports, right? So the reluctance is there is a built-in, we don't want the world to change. I tell people to go back and study England in the 1800s, one chapter in a history book, Luddites, okay? Study the Luddites. The port strike here in the US, we don't want any automation, but I want a Tesla to cost $10,000. So goddamn it, you fix this for me. That's why I voted for you. You said you'd do that. Well, it's impossible. You can't do that. You're never going to get all the promises that the AgTech industry is. The investors are never going to get their returns because we have engineers that go, I'm an NVIDIA guy. I got the T-shirt. Here's a real story. I'm not allowed in certain vendors' buildings. I have to meet them at Starbucks. You're like, what? I'm like, why are we meeting at Starbucks? You have a beautiful mansion of a headquarters. Well, because NVIDIA looks through our visitor logs, and if they see the competitor came in, they're going to like punish us. Grok's CEO had that happen with him at Infineon, and he wrote about it in Wall Street Journal. He's like, Jensen's the head of a mafia. So when I came here, my wife was like, if you come home and there's a black Cadillac in the driveway with some large gentlemen in black suits, I'm not opening the door. Go next door. We're not here to make any claim about NVIDIA being bad or anything negative. We're just saying technology is advanced, and engineers need to go advance. I'm sorry, it's the way it was. I also, in the early 90s, everybody drew schematics, and we had to go teach chip designers how to write code. We gave out T-shirts that said, real engineers write code. Right? And everybody came and said, I don't want to write code. I'd hand them a coloring book and a box of crayons. Well, go draw your pretty pictures. Everybody else is going to be writing code, and we're going to get chips done 10 times faster than y'all. And we did. Every chip on the market now is code. Nobody is drawing schematics. Well, maybe somebody in a basement in Iceland, I'm not sure. But anyway, so I guess my answer is more evangelical or more philosophical. We don't get better without change. Right? You don't get a smartphone if the engineer said, well, I'm a BlackBerry guy. I'm so good at BlackBerry that I'm going to retire as the BlackBerry guy. Well, you retired at 30 because BlackBerry isn't around anymore. That's what I say to those guys. But there's market conditions. Every market leader doesn't want anybody to stop using their technology. I understand that. But this is proven. By the way, we're one of very few people that submitted our chips to what's called the ML-Perf. It's a benchmark. It's an independent machine learning performance. You can go to their website. We finish first. And it's a pain in the ass to do that. It takes a lot of time to get through all of their tests. We wouldn't have done it if we didn't know we were going to win. We knew. But if I tell you I'm good, you're like, sales guy told me he's good. What's he going to tell me? The last presentation, we're sitting there and everything, well, that's a good question. Well, that's a good question. That was a good question. And I said to Robert, I said, I'm going to ask a bad question and see if they go, that's a bad question. Right? It takes change. It takes risk. You think Steve Jobs, I knew Steve Jobs. I got offered the job to build the first iPod. And my wife grew up in Iowa in a city of 800 people, and she said, "You want me to live in Cupertino?" I'm in San Francisco airport telling her, "I just got the best job offer of my life. I'm going to build this chip for Steve Jobs. I had dinner with him at his house, da 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 da." I get home that night. This is 1996. Kitchen counter is the yellow pages. Attorney dash divorce. I'm like, oh, hint received, message taken, thank you very much. But, you know, Apple was 0.1 cents per share at that point. They were building green and orange and stupid looking computers, and they built a music box.
I had one.
It changed the entire company. I was there when he pulled it out. He said, "I have 10,000 songs in my pocket." And I said, "No, you don't, because that thing is empty." The original iPod that he showed was a fake. That was Steve Jobs' best characteristic, was you never suspected him not telling the truth. Realize he never told the truth, but he built the best company on the planet. Well, now NVIDIA has passed him up. So I guess I'll wrap it up and say, change is hard. It's worth it. You wouldn't have an iPad, you wouldn't have an iPhone, you wouldn't have the internet if we still sent everybody letters and postcards. And that's what I say to people. Okay, if you're an NVIDIA place, there's plenty of other places that want to beat you, and they will, because they're adopting new technology and you're not, because you like NVIDIA. Good. Don't send your job application, because we don't want your kinds of employees. We want risk takers. We want startups. We want people that are innovating, that are driving the industry, not just sitting, taking a paycheck. So I think I'm out of time, am I?
Yeah, that is good.
All right, thank you.
Awesome.
So my name is Alex Fossil. I flew from Pittsburgh to come and visit FIRA, but I didn't come alone. I come with a number of people who are committed to actually focusing in robotics for agriculture, and not only the problems that we may have in California or in Pennsylvania, but actually globally. Even though this talk talks about expanding PA as a leader in tech for a global agriculture, I believe it's the story that is growing of the folks who love ag, love tech, and are committed to feeding the world. I want to make sure that I recognize the robotics factory that is in Pittsburgh. Pittsburgh is a region of people who, many blue-collar, hardworking. Who is from Pittsburgh here? All right, we have a few. Who has been to Pittsburgh? All right. Wow, you all, shocking. So it's a city that is proud, that went through a major crisis when the steel mills were not competing anymore, when the contamination, the pollution was actually causing some health problems. So that industry went away. The city struggled, but it came back up. And today we have a number of things such as advanced manufacturing, distribution and logistics. Health is big there. Also space, fintech, but today we're talking about robotics and artificial intelligence. This is a map, and I do not expect that you're going to be able to read the names, but these are more than 140 organizations that belong to the, broadly speaking, Pittsburgh Robotics Network. We have folks that are in space, manufacturing, inspection, in changing the way we work, the way we live, conducting research. We have great universities such as Carnegie Mellon University, such as the University of Pittsburgh, and many others. And we're not that far also from Penn State, in State College in the middle of Pennsylvania, a land-grant university that is committed to not only creating agronomic research, but also disseminating that to farmers. So the question is, okay, there's so much to do in so many industries. How do we somehow focus all of this talent into different specific areas? And for that, we have a Build Back Better regional challenge that is part of the policies of the Biden administration that provided an incentive for the region to catalyze or leverage all of this robotics work. And that led to the creation of the Robotics Factory. That is an organization that is not a factory of robots. It's a factory of robotics companies. It's an accelerator focused on bringing entrepreneurs, ideas, investors together to create more and more robotic companies that are going to be solving some of the key challenges of the world. And to do that, it does that through summits that bring industry leaders with the robotic companies. We had one related to aviation and robotics and just had another one. Right now, there's one going on with defense and robotics, but the one that I care for today is this one, which happened in April. That was the Ag and Robotics Summit. We brought growers. So Walt, one of the partners of organizing Go FIRA, was there, and several others from other places in the country. We also had OEMs, the likes of AGCO, CNH, Mahindra, and others, farmers, supply chains, but also we had many of those companies that relate to robotics in the city. And the idea was to look into what are some key pain points. What are some of the challenges that agriculture is suffering? And for that, we match exactly these two groups in a structured way to actually learn a little bit from each other. Now, you would say, well, how is Pennsylvania related to agriculture? Well, it has a long history. If I'm not wrong, maybe it was one of the first schools focused on agriculture that was there. Also, we have deep agriculture knowledge, world-class technology, as I mentioned, with this robotic network, and also agriculture matters to the state, so much that it might be one of the few states where the state budget has an innovation fund for ag. Also, this is not just about what happens in the farm, and I think that I'm preaching to the choir here because really it relates across the value chain, all the way from before, with all of the inputs to the farm, what happens in the farm, and also what happens after with all of the food processing, etc. Are you from Penn State? I'm going to get to talk about Penn State in a moment. Great partner. All right, very good. So when we talk about thinking about what are the problems that go beyond Pennsylvania, we thought that we needed to do something slightly different. So with some partners, we went and invited a few companies from Brazil to come and visit Pennsylvania. And we chose perennials because when you talk about robotics, when you talk about AI, it happens that if you have a crop that you plant every year, everything that you do in terms of planning and the history and the health of that plant, all that gets deleted and planted again next year. So the value is there, but it's limited. Whereas when you have a crop that is planted one year, and like sugarcane, harvested every year for 5 to 7 years, or when you have an eucalyptus that is planted and it grows the plant for 7 years until it gets harvested, Or in the case of citrus, right, you may have even 10, 20 years. So then the health and the history of that plant, also the way you structure the plantation, the rows, the communications infrastructure, all that pays off over multiple years. So we felt that that was a good group to start with. And we have some of them, and by the way, they're here with us today because we came to FIRA also to look into robotics technology. Suzano is the largest producer of pulp in the world, and they have more than 1 million hectares of cultivated eucalyptus. The reason I mention these numbers is because when one thinks about technology and how you create value with that technology, if you can multiply that by the adoption over a very large area, then that technology is more likely to pay by itself than if you actually sell it to fewer growers with fewer acreage. Also, the cost of sales of actually interacting with the farmers is easier when you have to deal with one organization that covers that amount of land than when, let's say, with 1,000 of those. Citrus-Suco is the largest producer of citrus. And who drinks Tropicana in this country? No? No one? Tropicana? I don't believe that. Yes. Okay, so Citrus-Suco's largest customer is Tropicana in the US. So you're drinking this juice from our visitors here. Funda Citrus is an organization that is also represented that actually pulls money from all of the producers in Brazil and looks into newer technologies that can make their industry more competitive. Let's change to one of my preferred crops, sugarcane. So when we aggregate the area of these three companies, Raízen, Terios, and Advos, we have 25% of the sugarcane raised in Brazil, the largest producer in the world of sugarcane. So these numbers matter. And when we look for applications of technology, these are great multipliers that make it very promising to actually run the numbers. And the previous two talks talk about numbers and adoption of technology, etc. That's why we believe that it is worthwhile reaching out to other countries that have a scale and bring them to see what the US, Pennsylvania, and the robotics community in general in the US has to offer. So just an example of what we have done. Not to say that this was a perfect program, but certainly is something that we are planning to improve and practice again. So talk about the ecosystem in Pittsburgh. We talk about, the Pittsburgh Robotics Network. And then we look in the city for one or two digital ag companies. We have found 4, which is great. In fact, we had a really good success story because Bloomfield had just been acquired by Kubota. In a year where exits are scarce and far and few in between, that was a really good story to show. So these are companies that are using the AI and the analytics coming out of Carnegie Mellon to actually improve agricultural operations. We had the presence of people from the state, Department of Agriculture, some representatives from the governor, and that almost became a vice president, by the way, Shapiro. We'll leave that topic for later. Then we went to visit some companies like NEIA, Carnegie Robotics, Near Earth Autonomy, all spin-offs of Carnegie Mellon. We went to visit Penn State. My goodness, that was a great day. Worthwhile the drive out to State College and back. There's plenty to see there, and by the way, plenty of new buildings. Of course, we were all wowed by the size of the stadium. Yeah. Then we spent the day with Carnegie Mellon. Of course, we look even for all of the students, Brazilian students there, so we had a really good conversation with them. And when we had a wrap-up, and of course, from Pennsylvania, we went to California. We stepped by UC Davis, and now we're participating here. But not only, and I want to speak of the FIRA USA organization. FIRA USA, GoFar, the company that organizes this, helped us organize the summit in Pittsburgh back in April. So we're very happy to participate and bring our visitors to FIRA, but also we brought some Pittsburgh companies, and I'm thinking of SCA Robotics, here represented by Spencer, Hellbender with Brian, and they are here, and they have their stand in one of the buildings, bringing some of the best prototyping and also serious production capabilities to help other companies get to market faster with good technology, good manufacturing of components that relate to cameras and microcontrollers and things like that. So if you have some time, pay a visit to them. I'm sure that you're going to have a good conversation. So I want to highlight some others also. So we have SCA, Hellbender. And by the way, I got to meet you guys and learned that you were also from Philly. So there was more presence of Philadelphia, of Pennsylvania here than what I thought at the beginning. And of course, Burrow, who you would have seen outside also there from Philadelphia. So just to talk a little bit about partnerships, part of the learning that we have been doing since that summit and putting the effort to actually bring the challenge of agriculture needs to an ecosystem that has so much technology is that it all goes through partnerships. No one can do this alone. So there is universities with different specialties. For example, Penn State with agronomic knowledge, Carnegie Mellon with the robotics, etc. We also bring organizations that are specialized in communication and events like FIRA, but Pixel Robotics Network being the entry point, and someone here keeps saying, I like the analogy, building bridges between different organizations, Alvaro, and the state also has been participating very much so. So what I'm reading here could be applied to possibly other states. It's not just about Pennsylvania, even though today for us is about Pennsylvania. But the important thing is that we need to continue looking for ideas and cultivating them and communicating them. We also have to promote our ecosystems globally. I think that FIRA does a fantastic job here. And of course, I'd love to see FIRA eventually have an East Coast version that would focus on the agriculture in the East Coast, and it could be in Pennsylvania. We need to continue to promote and establish partnerships. I did not expect that the train was going to be celebrating, but it's man, they're happy with this presentation. Okay, so I think that FIRA is doing a fantastic job, and they did it with us in the summit. They're doing it today. Great conversations, great exhibits, and I really love the practicality of the demonstrations. And of course, we need to continue. This doesn't stop. This is not something that you do 1 year. We continue just repeating the importance of agriculture to all those entrepreneurs. So I wanted to recognize that who should be giving the talk today is Kevin Dowling, the director of the robotics factory, but he's busy with his Defense and Robotics Summit. So he asked me, since we were coming here to represent them, wanted to also send you Ephraim, who has been instrumental to aggregate and invite the Brazilian companies to come to the US. So thank you very much for the partnership. And I want to finish with one thing that has to do with robotics, has to do with agriculture, has to do with partnerships, but it has to do with one of the most important things that we all need to be thinking. And it was mentioned in the earlier presentations. It's about safety. It doesn't really matter whether you're a temporary worker, whether you are an American worker, it doesn't really matter. But if you're a farmer or someone working in a farm, you want to continue producing food, and you want to go home safe. So certainly, robotics is going to bring a lot of help for the producers. We're going to see more food produced. We're going to see more profitability on the operations. But the one thing that we need to worry is about safety. And especially as we have more and more robots interacting with people, that no one hurts each other. So for that, I want to finish this conversation highlighting the partnership not only here with the visit to UC Davis and Penn State, but also a partnership with the University of Illinois at Urbana-Champaign. We have Professor Sala in the back. He's participating in FIRA for a couple times. And we are collaborating, and many other organizations. For this event, this is going to have the second edition, Safety for Emerging Robotics and Autonomous Agriculture. We call it Safer Ag Workshop, December 3 to 4 in Urbana, Illinois. So we have a number of organizations, including ourselves with Balanced Engineering, focusing to understand what are the best practices, what are the existing standards, what are the missing standards, and what are the safety case for agriculture in robotics, for robotics in agriculture, so that we have machines that can interact very safely, as we have seen, for example, Burro do. We had a demonstration today, so that machines and humans can work together, and no one gets hurt, and everyone goes back home. So with that, I invite you to participate if you are interested in the topic. And there are some flyers in the back that you can take with you as well. And I would like to see if there are any questions. And I'm not going to make this any longer because we all want to go for a beer or a glass of wine after a long day. Thank you.
Not to keep you if it's beer 30, but if there's questions, we have 15 minutes.
Yeah.
Come on, one question.
Yes.
Mel.
Oh, hang on.
What do you see as the biggest challenge on the safety side for getting us across the line? Is it the existence of the standards, the understanding of the standards by the developers, the farmers, and the agreement the portion of the responsibility? What do you see as the roadblock, the most significant roadblock to fielding and scale?
Can you respond with the mic so we can keep it on video? Thank you.
Yes, sir.
Yes.
I think that some of the challenges, there's not a single one, but one is that especially those companies that are starting, with a lot of excitement in creating prototypes of robots and things like that, think of safety from the first moment that you are designing something. Build safety from the beginning. And by saying that, you don't need to bring the rigor of a lot of standards and systems engineering and requirements and quality, because you're going to kill your project. It's going to be too expensive before you have proven your business case. But start, do a risk assessment. Just start understanding what are the key things that could happen, that could go wrong. Because as you mature your technology, you're going to continue to be building that safety in the system so that when you're done and you get your second or third round, for example, of funding, then you're going to have a system that is going to most likely meet the standards. And when lawyers are brought in, they're going to be much more pleased than if you didn't. So that is one. It's just having this sense that safety is important from the beginning. The other piece is having a very good conversation with product liability attorneys. Trying to understand, if you have a system that is going to be deployed, let's say, in low numbers, what is the level of risk that you can tolerate, and what's going to be your argumentation if you ever had a problem and you brought a lawsuit against you? If nothing else, you need to understand what you would get into, and that is going to motivate you to be thinking more about safety, and also of being very careful with your deployments. Maybe you're going to make sure that not many people are there. Maybe you're going to make sure that children are not present. Things like that that are common sense, but sometimes in the eagerness to actually develop, we may forget. And the last one at scale, Mel, is really making progress in this conversation that Sala is leading from within the University of Illinois, is the dialogue that needs to happen between regulators, technology companies, OEMs, and when I say regulators, I'm thinking of OSHA and others, and also the standards that are emerging to make sure that we all agree that we're doing the best we can with the existing technology to bring safe machines to the market.
Great, thanks.
We had one more question over here. Yeah, here you go.
Hi. Thank you very much for your presentation. And
That is a very good question. No, I'm just
yes.
kidding.
Actually, I really love that you mentioned, and you are mentioning for the whole presentation, the possibilities of making innovative business in the United States, and especially in Pennsylvania state. By our example, I understood that it's really nice place to make business. This is really nice place to grow technologies. This is really nice place to make investments. And I started our business 1.5 years ago in the state of Pennsylvania, and we are just one of example that we are following recommendations of our partners. For example, here is the founder of Orange Pavers, the company which made tens of millions of investments in American economy, being in Pennsylvania state, and this is just a wonderful state to make a business. So by our example, I can share that you're absolutely right.
Okay.
The second question relates on the possibilities of agricultural robotics that we are discussing today here in FIRA, in the West Coast. However, I really love the idea to bring FIRA to East. And I'd love to understand, where do you expect we have to do the FIRA in Pennsylvania state? Which part of the state is crucial? So just give an advice for organizers, and we will definitely follow up to organizers, because we need FIRA in PA state, definitely. And this is just a nice idea. Thank you.
Very good. So you're going to come with me later to talk to Wendelin and Mayalen and Alex, right? And look how we can promote the idea. There's a question over there.
Yes.
So I'm a farmer and former technologist, and so this is my first time here, so it's great to hear about the robotics factory in PA, this event here, organizations with the University of Illinois. And I guess being a former technologist and now a farmer, the difference between the products that we really see on the ground and the ones that are sold and the prices that are available versus the R&D stuff that happens at the university, and especially in California, your comments about regulators, products, OEMs, that discussion about safety is very near and dear to my heart in California. How does the industry help that? Because it feels, looking at all the vendors here, thinking about the industry in general, there's everything from, Tesla with international automation down to little companies that started out of a UC Davis lab or any other, somebody's garage. How do we help the industry, find its way and really get some of this stuff to places where it helps growers with, putting boots on the ground or robots on the ground and helping workers as well?
Yep. So what do you grow? What do you produce?
Almost everything that we do in the North State, so almonds, walnuts, pecans, rice,
Okay.
processing tomatoes, wine seed.
Okay, so many of those are really labor-intensive operations. Yep. Okay, very good. Thank you. So there are things happening. So for example, when you look at the the OEMs, they are investing their money in engineers, representatives, etc., that are working, and they get together to create the standards that will eventually guide how you build a complex machine, a robot, or even before a robot, but then let's say an autonomous tractor or something like that. Any one of the machines that we have seen here, so that the architecture and the code and everything is done with a level of quality to answer towards those risks. So people are investing. The part that is not necessarily resolved to the satisfaction of everyone is, well, do those standards represent the best we have as it relates to being able to argue, right, that yes, you built a machine again according to those standards, and can that be a good argument in court? And that piece is a conversation that is going, because on one hand, the regulators may not agree with the standards, and they have their own, like in California, this prevention of tractors running without an operator, right? But also, I don't think that right now, I don't think that everyone in the industry, and I'm thinking of OEMs, are completely comfortable with the existing regulatory and standards collection to say, yes, this covers everyone's or limits the risk of a major lawsuit. But I would say what do we need to do is to participate in events like what Sala is leading, and maybe we have been talking that maybe right now is the second edition in Illinois, but it has to come maybe to California. So it's focused on the challenges of California, and you bring regulators, and that conversation is a very well-structured conversation that brings factual, statistical understanding of accidents, of risks. OEMs are in, farmers are in, etc. So what I would say is just join one of these conversations, and so that we can, as an industry, continue making progress. There's one more thing, I want to take advantage of your question, and I promise that I'm not going to use the next 3 minutes. So we can make the machines safe, but there's one thing, one aspect that is perhaps one of the most critical factors in how we humans collaborate with machines in a safe way, and that is communication. So if I'm working in a field, let's say I'm doing any task with a tractor, and I'm running out of fuel, and I radio my tender truck or fuel truck to come in and meet me, or if I'm seeding and the seed truck is coming, whatever, right? So I look at the guy, he's coming, and I may wave and just say that I'm going to finish this row and come back, and we're going to meet over there. And there's both language and what is the word I'm looking for? Verbal, thank you. Verbal and non-verbal communication. And we know each other, so he understands what I'm trying to do, and I don't need to explain a lot. Well, between people and robots, I think that the establishing an intuitive language, especially for the non-verbal cues, is going to be critical. And it's one that doesn't require reading, hundreds of pages in how you operate the robot. It's more like reusing what we humans do very well among ourselves. I can't characterize that very well, but it's this idea of automation, state and intention communication. If you and I are talking, what you want to know from me is that, what is my state? Am I okay? Am I moving? And also, what is my intention? What I'm going to do next, right? And also, I want to know that from whoever is collaborating with me. How are you, and what are you going to do? That way, we can collaborate. So this automation, state and intention communication is one that is begging for a standard. So all farmers globally can talk to the farming robots the same way. That's my 2 cents to this conversation. More questions?
Maybe time for one more, or?
Well, I wanted to thank you. I mean, my goodness, this is the last talk. So thank you for putting up with this, for coming and being interested, for some of the questions. And today, let's go get some rest and drink some beers and just laugh. And tomorrow, let's continue building great robots to help the producers feed the world. Thank you.
Thank you very much. Thank you to all of our panelists and our guests. So enjoy your evening. Enjoy Woodland. Thank you for being with us at FIRA USA 2024, Day 2. We'll see you tomorrow morning. Our gates will be closing at 5:30 right now, right away. Just a quick reminder to all that we do start tomorrow morning at 8:30 in the Wait Hall.
Hi there. How are you? I'm just wondering. Good. Thanks for help. I was wondering. So they're getting recorded, right? The presentations. Will they be available somewhere?
Oh yeah. So I'm going to give them all to my group.